Now in this lecture, we are going to implement queue using linked list in practice. So we are going to create all methods that we have discussed in our previous lecture in practice over here. Now here we have linked list class like this. So this is linked list class that we have discussed in our single linked list section. So I've just copied the code from here and pasted it over here. So that's why I'm not going to go to the details of this code. So if you want to know more about this linked list class over here, I advise you to go back to single linked list section of this course. Now here we have linked list class, so we have node class. So this is used inside this linked list class for creating nodes in the linked list. So these are the two files that I've created over here, which will not be discussed in this lecture because we have discussed them in our previous lectures. Now here then I have created queue linked list file. So inside this one I'm going to implement queue using linked list. So let's get started. So here the first thing that I'm going to do, I'm going to declare our class like this. Public class queue linked list. So here inside this class, the first thing that I'm going to do, I'm going to declare list. So this list will be the type of this linked list over here. So it's going to be like this, list. Then inside constructor, we are going to instantiate this linked list class over here. So as we said in our previous lecture, when we are creating a queue using linked list, we just need to create an instance of linked list class over here. So with this, the head and reference values will be set to null, because when we are creating an instance of linked list class, it says head and tail references to null without creating any node in this case. So here inside constructor, I'm going to create an instance of linked list class. So it's going to be like this, queue linked list is equal to new linked list class. Then we are going to print out to the console saying that the queue is successfully created. So I'm going to print out system.out.print the queue is successfully created. Now with this, we have successfully implemented creation of queue using linked list in this case. Now let's see how this is working in practice. So here inside main class, I'm going to create an instance of the queue linked list class over here. So here I have created it. Now let's run our code to see how this is working. Now after running our code, we see that we have an error in our code. So inside this queue class, I have forgotten to put the parentheses over here. So if I put parentheses and run our code, you'll see that it's printing out to the console saying that the queue is successfully created. So we have created a queue using linked list successfully. Now let's see what's the time and space complexity for creating queue using linked list. Now in this case, we are just creating an instance of linked list class over here. So this will take O1 time complexity. Then we are printing out to the console this message that queue is successfully created. So this one also will take O1 time complexity. So the time complexity for creating queue using linked list takes O1 time complexity. Now the space complexity is also O1 because here we are not allocating any memory when we are creating an instance of linked list. Here we are just declaring the head and tail references and set to null. So a space consuming operation is not happening over here. So this means that the space complexity for creating a queue using linked list will be O1. Now let's continue to create the methods that we have discussed in our previous lectures. So the first method that we are going to create is empty method. So I'm going to comment out over here is empty. Then I'm going to declare our method. So we know that isEmpty method returns true or false, which is Boolean type. So the return type will be the Boolean. So the name of method will be isEmpty. So it's not going to take any parameters. So we are going to declare our method like this. So here inside this method, the first thing that I'm going to check, if this list head points to null, in this case, it means that our linked list is empty. Otherwise, it's not empty. So here I'm going to put if condition like this. If list dot head is equal to null, it means that our list is empty. So I'm going to return true. Otherwise, I'm going to return false. Because if head points to some nodes over here, it means that we have some elements in our queue. So this means that we need to return false in this case because our queue is not empty. Now let's run this method for the queue that we created in our main class. So here we have created new queue using linked list like this. So here I'm going to create a variable which will be the type of Boolean to see the result from isEmpty method. So then I'm going to call isEmpty method for this new queue that we created over here. So it's going to be like this. Then I'm going to print out to the console this result that we are getting from this isEmpty method. Now if I run our code, in this case it will return true, because in this case our queue is empty. Now if you see in the console, it says that it is true. So this means that we have implemented our method successfully. Now let's see what's the time and space complexity for this method over here. So it's obvious that the time complexity will be O1, because in this case we are just checking the head reference, and based on that we are returning true and false. So these 3 lines of code over here will take O1 time complexity. Now if you combine them together, it will be O1. Now the space complexity is obviously O1, because here we are just checking the head value, so that's why a space consuming operation is not occurring over here. So this means that the space complexity will be O1. Now with this we have successfully implemented isEmpty method using linked list Enqueue. So we are going to continue to the next method, which will be the Enqueue method. So I'm going to comment over here Enqueue. Now we know that when we are enqueuing element to the queue, it has to be inserted at the end of queue. So in this case, when we are using linked list, we have to insert it at the end of linked list. Now when we are talking about linked list, we have implemented insert method in our linked list class over here, which is insert in linked list. So here it takes 2 parameters. The first parameter is node value and the second parameter is location. Now if we set the location which is greater than the size, in this case we are inserting an element at the end of this linked list over here. So we are going to use the same logic over here. We are going to call our method with the parameter which is equal or greater than the size of linked list over here. So here I'm going to declare our method like this. So the method will not return anything, so that's why I'm going to create it like this: public void enqueue. So as a parameter, in this case it's going to take value. So this is the value that we are going to enqueue to our queue. Then after doing so, we are going to call insert method of this list, linked list that we created over here. So the parameters in this case will be different. So here it's going to call insert linked list. So here we need to provide 2 parameters. So the first parameter is node value. So this value that comes from this parameter over here we will put over here. Now we need to identify location. So as we said, if you put location parameter, which is list size or greater than list size, in this case it's inserting element at the end of linked list. So here if I put something like this, linked list of size, it means that it's going to insert this element at the end of linked list. Now we know that when we are inserting an element at the end of linked list, first we are creating a new node and assigning this value to it. Then we are setting the next reference of this new node to null, and tail has to point to this node over here. So here we are updating the last node's next reference to point this node and tail reference to point to this node. So with these 3 lines of code, we are inserting an element at the end of linked list. So same operation will be implemented over here when we are calling this insert linked list with these parameters over here. Now after doing so, we have successfully inserted an element at the end of the queue. So here I'm going to print out to the console saying that successfully inserted value in the queue. Now with this we have successfully implemented Enqueue method in our queue over here. Now let's see how this is working in practice. So I'm going to call Enqueue method for this queue over here. So we have created queue, and based on this queue I'm going to call Enqueue method. So for example, I'm going to insert 10, 20, then I'm going to insert 30. Then after doing so, we can also check that if this queue now is empty or not. So I'm going to keep this part of code as it is, because I want to check that if our isEmpty method returns false if we have elements in our queue over here. Now if we run our code, when we run our code, you see that it says that the queue is successfully created. Then we have inserted 3 elements to our queue over here. So 10 is successfully inserted, 20 is successfully inserted, and 30 successfully inserted. Now at the end, as when we call isEmpty method, it returns false, because in this case we have elements in our queue. So this means that this queue is not empty anymore. So that's why it's returning false in this case. Now with this, we have successfully implemented Enqueue method. Now let's see what's the time and space complexity for this method over here. Now when we are discussing linked list, we said that when we are inserting an element at the end of the linked list, in case of single linked list, in this case the time complexity for this method takes O1 time complexity. So when you go back to the linked list class, you can see that when we are inserting an element at the end of linked list, this part of code is implemented. So this part of code takes O1 time complexity. So that's why this method over here will take O1 time complexity. Now after doing so, we are printing out to the console this message, so this one also will take O1 time complexity. Now if we combine all these complexities over here, it will take O1 time complexity. Now the space complexity is also O1 because whenever we are calling Enqueue method, we are just inserting one element to the queue, so this means that it will take O1 space complexity. Now with this method we have come to the end of this lecture. So in this lecture we have implement creation of queue using linked list, then we have implement isEmpty method, then we have implement Enqueue method. Now to make our video shorter, that's why I'm going to create other methods in our next lecture. So hopefully everything is clear about this lecture over here. So see you in the next lecture. So in the next lecture we are going to implement the queue method, pick method and delete queue method. So see you in the next lecture.